Hello, today we are going to do some Python experiment with what is called steganography. Okay, so basically, I have put a lot of information on this notebook. Some of it is useful, some of it is maybe more advanced, so don't panic too much about all that. What matters is maybe to understand what is steganography. Steganography is the science of writing hidden messages so that, just the sender and the recipient suspect the existence of a message. Like, I have encoded a message in this picture. This is the original picture. It's a PNG file. And I encoded a secret message in the picture. So we are going to see what I encoded for you. So, I think this is very interesting, especially for those people who are interested in security issues. Many terrorist networks are actually using this to communicate between themselves over social networks, and nobody knows. You would never suspect that there is something or a hidden message here. So steganography permits, it's a technique that permits to hide messages in image, audio, or video files. And here we will apply it to an image, so a picture per se. There is a difference, sometimes we are a bit confused with all those terms. There is a difference between steganography and cryptography. In cryptography, you encrypt a message so that, people may know, well, this is a message, but I cannot decrypt it. I don't understand. I don't have the key. Okay, so, and because sometimes the message are well, everybody can see it, but nobody can decrypt it. So it arose suspicion. Okay, but with steganography, the idea is that you never suspect that there is any hidden message in the media file, the image, audio, or video file. Be careful as well, because I know that in social networks, people are exchanging pictures and things like that. But it's easy to introduce a malware, a little code, so that when you download that picture on your computer, you are going to get a virus. So be careful with the exchanging pictures with people that you don't know. Yeah, okay. What we are going to do is very simple. Of course, in order to understand what is done here, we need to talk a little bit about what is a pixel in a picture. And in order to do that, I have prepared a series of code lines, but I don't want you to look at that actually. What I need is, well, let me first to go and, so I'm gonna get this picture here, the patrick.png file that I put in Brightspace as well. So again, okay, when you upload the notebook that you have received on Brightspace, what you have to do after that is to to upload the picture. So the picture is in Brightspace as well. And then I guess you have saved the pictures onto one of your directory in your computer. And you go on this little rectangle here, and you click on this icon here. So you are going to be able to go and catch the file that you need. Okay, so so if you click here, it goes to my computer, and I'm gonna get this thing here. Oops, it's not the one that I wanted. So let me go back here. Let me go to downloads. Where is it? Well, I guess this is this one here. Open. So you see that you will need to do this exercise. You will need to have a picture file with an extension PNG, okay, not an extension JPG. But I mean, if you have a picture of yourself and you want to hide a message in that picture or any other picture, all what you need to do is when you save the JPEG picture, save as, and then you change the extension, you put PNG, so it will change the format of your picture. So basically, I don't need that, I can erase it, but just make sure that you have a PNG extension to the picture that you are going to test. So now I have a pictures. Maybe the first thing that I want to do with you, okay, I'm gonna run this, okay, don't worry, okay, I even didn't include that in the notebook that I put for you on Brightspace, but let me run this thing here, and you see that it's gonna take this picture, the picture that I just imported or uploaded. So that's this picture here. Let me do that here. I'm gonna close that now. It ran it, and then it generated this thing here, okay? And basically, why is it that I decided to show you that is that, sometimes we know that, there are pixels in pictures, but what is a pixel exactly? It's a pixel is the, I think I have written it here. So a pixel is the abbreviation for picture element. It's the smallest unit in a picture. And basically here I have decomposed this file into, you can see some squares here. And in each of those squares, actually there are 100 pixel in that direction and 100 pixel in that direction. So all in all, there are basically 10,000 pixel in this little square, okay? So a pixel is a very tiny picture element that are put in an adjacent way, and there are 10,000 pixels here, 10,000 pixels here, okay? And eventually, if you look at this picture here, you can see that there are 87 big square. So there are all in all 87,000 pixels. Plus, this little on the side, you see that there are some pixels here. So all in all, okay, in this picture, there are about 900,000 pixels. So it's a lot of data that are included in a picture, in a digital picture. And we use, or people use the fact that there are so many data in a picture that it's very easy to introduce a little code or a little text or a little message and to hide it in so many pictures, in so many data, so that nobody can see that there is a secret message here. So anyway, all that to tell you that in that simple picture there are 1 million pixels, okay, and all those pixels will be colored, okay. So and in order to explain the color, I have draw here a little cube. And you remember from primary school that a color is made of 3 primary colors. You have the green, you have the red, and you have the blue. Basically, it goes from a range. So it's a Cartesian graph, and this goes from 0 to 255, 0 to 255, and 0 to 255. So it's 3 dimension. So it's a cube. So, for example, if you want to have a black pixel, you would position yourself here, okay? So it would be on the blue dimension, you choose a value of 0. on the red axis, you would choose a value of 0, and on the green axis, you would choose a value of 0. So the 3, 0 would locate yourself here, and basically it means that you would have a black pixel. So if I go in this thing, in this picture here, I know that those things here, okay, the value, the encoded value of the pixel, of each of those pixels must be very close to 0 for each of the 3 primary color. And you can see that, if I want to have a red, a pure red, okay, I would pick a value of 255 for the red, and I would choose 0 for the blue and 0 for the green, and that would give me a red. If I want to have yellow, I pick 255 for red, 255 for green, and I would pick 0 for blue. So the combination of green and red give you yellow. And white is, you would get 255 for the 3 dimension, and that would give you a white color. So so that's about what I wanted to say about that. But if you look at that, okay, sometimes when you go to Excel and you play with the color, okay, you receive a window like that, okay, and you can see that actually that's what they ask you. You can pick a region in this image, and then you can see that the red is given a value of 191 out of 255. Green is 29, and blue is 152, and that will give you something which is basically some kind of magenta color. If you go to Excel, I did it to show you, but if you go here and then you pick more colors, you get something like that. And then if you pick custom, you see that you can choose whatever you want. If you pick a value like that, oops. You can enter the number that you want, or you can, not sure why it did not change, but like, let me put a 100 here, 24 here, and 45 here. And then, that's gonna give you this specific color, okay? And so that's the basic idea behind how we put or how we manage to have a color pixel in the pictures. Okay, those numbers will give you this color. And imagine, okay, you have basically 356 choice among the blue, the green, and the red. And basically that would generate more than or close to 17 million possible colors. So it's more than the human eye can detect, probably. Well, this being said, okay, those numbers, usually when you communicate with a computer, you communicate in binary system. So those numbers are rewritten in a binary system instead of a decimal system. And I put some information about binary system here. I'm not gonna go back to that. Okay, if you are interested in knowing more about the whole idea, how it works, you can read the binary system. I provide here a link to a calculator, how to transform a decimal number into a binary number, and vice versa. Basically, for example, let me, so, I will let you, if you are very interested, you can read in details. If you are not interested, you can just run the code, and that's it, okay? But basically, you can generate, for example, imagine that in a box like that, you pick a value 149, okay? And that value can be converted into a binary system as, you know, a 8 bits or 8-bit number, okay? And that would be 149 in a binary system would be 100100101, okay? And the whole idea of steganography, or at least the method that I have used here, is basically to change the last bit that you see here, okay? And this is called the least significant bit, okay? So, for example, if I change this to a 0, okay, all those bits are either 1 or 0. That's the way the binary system functions. Okay? And if I change this last bit from 1 to 0, actually I'm changing the number from 149 to 148. So, you know, if I change this, you know, the last one, the one which is on the right, okay? If I change that, you know, I'm creating a very tiny changes in the spectrum of the color that I show you. Remember, 149 could be, for example, one of those 3 numbers that you put here, okay? So I go from 149 to 148, and you can play with your Excel and see exactly what it's going to give you. But you will see that it will not change the perception or the perception of the color that you will perceive, actually. So the whole idea of steganography using least significant bit transformation is basically to play with that rightmost bit number here, okay, which would change this value into 148. All other bits would change the value to a much different value, like from 149 to maybe, I don't know, 260 or 300, you know, with color it cannot go beyond 255, but you know, it would be a very different number than 149 or 148. So basically that's the main idea. So now you can introduce a text in those numbers, in particular in the least significant bit of the binary system, in this way. So, for example, you know, a message like, imagine you want to code hello world, or I don't know, any other sentence, okay? Well, this can also be coded, well, this can be transformed into ASCII code, okay? So the H is 72, the E is 101. I have put, I think, a table like here, okay? So you can see H is, if it's in capital letter, it's 72, and you can see the equivalent of all those letters here, okay? And basically, if you have a message that you want to communicate, you transform the H into 72, E into 101. Those are decimal numbers, and you can transform them into binary numbers. Of course, you never have to do it yourself. The computer will do that, or the code will do that for you. Okay, and this will eventually be transformed into a long string of bits. Okay, and basically, imagine that you have three pixels, okay, which are given in our original decimal space by red, blue, and green. I'm sorry, red, green, and blue. Those are the decimal color that we attribute for the first pixel. For the second pixel and the third pixel, those are the decimal numbers that we pick. And you would have 1, 2, 3 pixels, okay? And you see that well, those numbers are very close to each other. Well, those three are very close. Those three are very close. Those three are very close. So in this, in the red, green, blue cube, those are very neighbor colors. Okay, so basically, for the eye, it seems to be the same color. And of course, you can represent each of those numbers in a binary system as this. Again, you have table that you can use, and if you look at that, you can always go from transform a decimal number. I don't know, 149. You can calculate that, and you get the binary value here. Okay, so that's basically what is done here. Okay, you have those decimal numbers for the three colors of 1 pixel, and you can transform that in a binary numbers. And now imagine that those are the pixels in your original picture, and you want to introduce a secret code. Okay, and let's suppose that you want to send some money to some people, and you say, well, you need to introduce a specific code, like the code 365, and you can hide the information 365 into the image. All what you would need to do is to get a binary representation of 365, which is actually, I did it before, and that's this number here, okay? And you would need to hide this into that, okay? And what you would do is to pick the least significant bit that we have seen. It's the last number here, the last number here, the last number here, okay? And you would simply overwrite the one that you see here. You would put it here. The 0, you would put it here. So you transform the 1 here as a 0. The 1 it can stay here, etc., so that eventually you would get those three pixels with the 3 decimal values that you need to introduce for the 3 colors would be changed from this to that. And by doing that, okay, if you look at the new pixel values, okay, well, in decimal number, that would be this, so not much change with respect to that. And in terms of color, it would give you that instead of this, okay, which appears, to me at least, exactly the same, okay? And that's if you want to hide a specific number. But if you want to hide a specific character like a G, okay, well, it's the same thing, okay? Like if you have this series of pixels, okay, you can hide the G by changing the last significant bit, those number here. You change it into those number that you see here, and please read the text that I put. And then eventually you'll be able to hide a character like the character G. Of course, you want to hide a message, so it would take much more time if you want to do that manually. But basically people don't do that manually. Okay? People use a library, and the Steganography library permits you to do that. Okay, so it's very simple. You simply have to install into your Google Colab environment the library called Steganography. So you run this thing. And then you have to import a class, which is called LSB, for least significant bit. So it's the same procedure as we did before, nothing new in terms of how to install and importing a specific module from the library Steganography. And here you can simply you use this class to create an instance or an object and you are going to apply a function, and in that function, in the function, you put the argument. The argument should be the name of the original pictures, and then basically as a string, you have to introduce the what you want to code. So in the pictures, I want to introduce a message. Dear students, I hope you have some fun with Python. So if I run this thing, okay, I'm basically encoding in the original picture this message here. And then I can save it. I'm using this function to save on this object or this instance of a class on this object called secret. I'm saving basically whatever has been assigned to secret. So that's basically the original pictures encoded with this message. And I'm saving that under the name Patrick encoded image PNG. And that's it. Okay, now I have a new pictures. And if I open it, you don't see any difference with the original pictures. Okay, but now there is a message here. And imagine that you receive this message. How can you decode? How can you get the message? Well, all what you need is to use the reveal function. So you use the method of the class LSB, and you apply the reveal function to the transform PNG file, which has encoded the secret message. And if I click on that, you can see basically my message. And that's it. That's basically how you can use a library in order to encode the secret message. So have fun with that, and if you want, you can send me pictures with a secret message, and I will be very happy to read the secret message that you want to send me. And of course, for the rest, okay, the rest is more difficult. Okay, what I have tried to show is basically if I like in all what we have seen together up to now, we have never do any coding per se. All what we do is to use library where everything has been coded. Okay, now so basically, of course, well, there is some code here, but I mean most of the code that you have to introduce are basically calling some function which have been coded for you. Okay, but if you wanted to do that by yourself, well, you would need to introduce some piece of code. Okay, and here in the last part, I basically read that using Python, pure Python. So basically, I try to minimize the number of libraries that I'm using. I don't use Steganography library, and I can encode the same message, and I can decode it. So for my students in this course, I don't want you to go through that, but I want you to understand the following. Okay, when I'm invoking or when I'm calling a library, what you have to understand is that it is not truly coding per se. I'm using code pieces or a line of code that have been coded by other people. Okay, but I mean, if I run this thing, okay, and eventually I will be able to. Okay, this is the message which has been encoded, and I can again take the original pictures, look at the white and the head, so the number of pixels in the white and the edge of the picture, and you can, if you multiply this by that, you will see it's very close. It's a bit more than 900,000 pixels in the image. You can see that the image is this one. It's the original image. And if everything has been coded into something called data. And you can see that this data is basically a big matrix with, the kind of notion that we have introduced, okay? This is the first pixel, this is the second pixel adjacent. So it's the first pixel on the top of the image. And then you have the second pixel, the third pixel, each of them given with 3 numbers, okay? And this is, the last pixel on the bottom of the image. And you see, like, it's very black, so the number should be small, okay? 12, 23, and 43. So it's not pure black, but it's small number, so it's very dark. Anyway, once you have that, and I don't want you to go because I don't want you to discourage. I want you to understand that basically what I show you when I tell you, well, let's use some library. All what you need is to call those libraries, but you never really code anything in Python. But we can code that ourselves if we want it. Okay, so anyway, now I can introduce my pixel. And, it's kind of very difficult because we are using bitwise operators, and it's way beyond the type of code that I want to do with you. But anyway, all those things will encode. Now I have a new pictures that I have saved, which include the secret message, this one here. And we can decode it. Again, I'm not using the Stegano library. And if I decode, eventually, you can see that I have decoded the message. Dear students, I hope you have some fun with Python. Okay, and you can also, using the same principle, you can also try to decode the picture that we have encoded with the Stegano library. And if I use the same principle, I would be able to decode. And you see, dear student, I hope you have some fun with Python. And there are some other characters. Well, it's related to how you introduce, whether you introduce or not a stop symbol to say, well, the message is finished. Okay. So anyway, that's basically what I wanted to show you, to introduce the principle of steganography, to warn you that actually, if you are interested with security issues, terrorist group use these kind of things to communicate between themselves. They have avatar in social networks, and then they keep on changing the avatar so that and other people from the group are able to see the message that they want to exchange. But I mean, you can do that for fun. You again, okay. What I suggest to you is look at what you can control. Okay, and you can, if you read the text, you can learn a little bit more about what is a pixel in a picture. Look what you can control. Basically, here, all what you would need is basically this line here. You have to install Stegano library. I think that I had run this before, okay, but there is some chance that when you will run it for the first time, you get a warning that you have to restart the runtime. So probably see here, you must click on restart runtime button above, okay, because I run it before recording. I don't see it, but most likely you will need to restart. So there is something here that you have to click in order. Maybe I can close it. Not sure whether. So see, restart runtime. Okay, it means that I'm erasing everything. So most likely, if I do that again, I'm not sure, but No. So it keeps in memory the library. But I mean, again, okay, if you run it by yourself, there is a chance that you will have to press on a button which will be below the last line, and you just press restart one time. Okay, you press it, and then you will be able to run this line. And then all what you need is basically to change. You come here, you type, okay, if I don't know if this is Laura who is trying this code, you type Laura because you have a picture which is called Laura, and then you introduce a specific code, hello professor, okay, and that's basically all what you need to do. Okay, and basically you, of course, you change this to LoRa encoded image.png, and that's it. Okay, you have so you can see what you are able to control. Okay, and basically when you want to reveal, if you want to if you send it to me, okay, I would need to use this, okay, to reveal. You would need to send me this picture that you are going to save. So it will be Laura encoded image.png. You send that to me, and then I will use Laura encoded image.png here in this reveal function, so that I will be able to read basically what you send me. Hello, professor. Okay, so try to do things like that. Okay. And see exactly what you control. Again, the golden rule is that the more you try this kind of little things, and the more you feel at ease with Google Colab, importing, exporting, uploading file into your Google Colab environment, and basically then you will be ready to start to exploring more complex things. But start with the easy stuff. Okay, that's basically what I wanted to cover today with you.